Okay, mija. This is the first one of three so far, maybe four, of plotting and visualization. It's chapter 901. We import the usual stuff. In example A, it's a simple scatter plot. We have the values for our x, the values for our y. We execute the constructor and plot a scatter plot with x, y, and the marker, which would be the dots, the character for the dots. Then we show the plot. And there you go. 5 to 20 on the y, data, and on the x, 2 to 6. For example B, I'm going to comment the A, and the rest of it. Example B is saving figures to the disk as JPEGs or PNGs or TIFFs and so on. We get NumPy to give us 10 values. Here I'm printing the type of the NumPy value, NP data, and the data itself. Execute the constructor for the figures and the plots. And here we're setting a big size for the image that's going to be recorded, and we plot the NumPy data. It's important that you save the figure before executing plot show. And remember that DPI is dots per inch, and a normal good plotter would be 200-300 dots per inch. This gives us the surrounding frame. I set it to gray, and small, the frame around the plot. That's the type. This is the type of the NumPy data. It's ND array, and we have 0 through 9. Notice that the image is big, and also that it has been saved to the disk. All right. And here we have the image. I'm gonna open it in my Photoshop emulator here called GIMP. It's free. And here we have the image. If you go to view it at 100%, it's nice, good resolution with a 300 dpi. The size of the image in the disk in inches is 22 by 12, and pixels per inch is 300. All right, let's move to example C. In example C, we're going to do a simple horizontal bar chart. We instantiate this. You can do also instantiate the figure where the axis will be plotted. AX is for singular and AXS is for plural, but you can use plot subplots to do just one axis, one figure, one axis in the figure. The X label is going to be performance. The title of the whole thing is going to be how fast you want to go today with the font size, and the title will be dark blue. Here we have our little tuple with 3 runners, and we use numpy arrange with the length of that tuple, which is 3. This could be a 3 here explicitly, but if you were to add more runners, it's good to use the length of the runners tuple, because then you don't have to change this. For the performance of the running, we're going to use a random number, and for the error bars, a random number as well. Let's take a look at the first one. And this one has more arguments for you to explore, but the first one is the simplest one, where we have the Y axis positions, the performance, which is a random number, and it's going to be gray. Here we set, this is not going to do it right now, and the tick labels, we're going to use that for the next example in this one. And this shows the plot but doesn't save it. So here we have it. The title is dark blue in 18 size of a font, and these things are random, no error bars here, and they are gray. Let's comment that one and uncomment the other one so you see the effect of the other arguments. All right. Now we have this beautiful one where we have the colors for each of the bars: dark green, lavender, and purple. We have the error bars, these 3 bars here. They are random too. They've been aligned in the center of the bars, and the error colors is gray. You could invert the axis. You see it says Harry, Mike, and Aubrey. If you wanted for some reason to reverse that order, you can use that. It's AX, not axis. Okay. And now we have them reversed and with a different set of random numbers. All right. Let's move to example D. In example D, we're going to do matplot figures. The type of a matplot figure is this, matplotlib figure. That's the class here. We instantiate the figure. We're going to print that type and an ID, which is like a number that identifies that figure uniquely. And we're going to do the same for the plot. Display its type and its ID. Now here we have 4 plots that are going to be placed in the same figure. So the figure object is the same, but the plot objects are different. Now 1, 1, 1 would have meant just one plot in the figure. It's a 1 by 1 grid. 2, 3, 4 would have meant 2 times 3 is 6 images, and that would be the 4th plot in the image. 2 times 3 plots, and the 4th plot in the image. And an alternative syntax would be to put commas between the numbers. So what do we have here? We have a 2 by 2 plots, which is 4 plots in one figure, the same figure, plot 1, 2, 3, and 4. And we show it. So there's no data. We haven't established any data for any of the axes. So this is the default that matplotlib would give us from 0 to 1 on both axes. We have 4 in the same figure. Moving on. We're going to go to the last example for this video. Example E. What we're going to do here is do 4 plots, but we're going to put them on the same I forgot what this one does. Yeah, on the same figure. Okay, the first thing that we are going to display here is the styles available for our matplotlib. This is a list of the styles that are available. The default one displays like that. Okay. For if you wanted to change it, the style, I've chosen classic here. This one adds a grid and some coloring in the background. There are others that do the opposite, that do the gray on the plot and the background stays the same. You can experiment with these guys by putting them here. Now, a histogram displays numerical data by grouping data into bins of equal width. Each bin is plotted as a bar whose height corresponds to how many data points are in that bin. Bins are also sometimes called intervals, classes, or buckets. The first one that we showed is a histogram. It has 40 bins, dark orange, and the translucency of the color, I set it to 0.3. If you take a look at what happens with the translucency, is that we get that kind of transparency here in our histogram. If we change this to a number closer to 1, for example, say 0.9, 9 would give you the full color. 0.9 is going to do a little bit only of transparency. There you go. The second plot here is a scatter plot. We're going to use NumPy to give us 30 numbers, and their values are going to be random, and the color is going to be orchid. That's the second plot here. So NumPy gave us 30 on X and Y, and random numbers for the scattered values. On this one, random values, dark green, it's a line plot. It's just a straight line plot. The line style is dotted, and the width of the line is 0.5, half of what it would normally be. That's this one down here on the left, dark green, dotted. obviously I would like to make the lines a little thicker. Let's try that. Still, I want them a little bit thicker. Oh, I'm working on the last one here. I'm sorry. I'm sorry, baby. This is the one that I wanted to change. There you go. All right. Now, lastly, you have this function, subplots adjust, and it'll adjust the spacing between them. If you notice right now, the spacing is kind of too much for my taste, right? Especially if you make it big. Spacing between them is a little bit too much. Let's try to change that a little bit by making the spacing. This one, let's see what it does. Let's set it to 0.3, white space. That takes space from this area here, in between them, in that sense. Now, if we also wanted to reduce the space from the rows, it's H space. Cool. All right, baby. That's this one. I love you.